Hello, this is Mrs. Griffin with the Unit 1 Lesson 1 video for Common Core Geometry. And in this lesson, we're going to work on naming and defining different geometric objects, namely the points, lines, segments, rays, and angles. So in order to begin, we're first going to talk about these things called undefined terms. And what undefined terms are, the most simplest basic building blocks of everything in geometry. And so those are points, lines, planes, and sets. And we call these undefined because, as I said, they are the simplest geometric terms and they are the building blocks of everything else that we do in geometry. All other concepts in geometry are based on them. So, next thing we're going to talk about are some notations. So one of these four terms above is line, and this symbol here with a double arrowed hat on top of two letters is a symbol for a line AB. And what that would look like is an extended infinite line with end point or 2 points on it, A and B, and those points could be anywhere on that line. Now, if the hat on top of the two letters has no arrows, then that is now a segment. And what a segment AB is a portion of that line. So it would be only the part in between the points A and B, and these would be called endpoints. Now, if there's only one arrow, then that's a ray. And a ray would have an end point for the first letter and would go infinitely through the point for the second letter. And it doesn't have to go left to right. It could go right to left, up and down. It really wouldn't matter. But what it means is that it would have an end point at A and go through point B. And then if it has no hat at all, this is a reference to a number indicating the measure or length of a segment. Okay, and that would always be a number or variable. Now, angles. Something else that's very important in geometry. They're always going to be measured in degrees. Notation would be this angle symbol, and you could name an angle several different ways. You could name it using 3 letters, using 1 letter, or using a number. And what would happen is that your angle would always look like a corner, where the angle is the actual corner in here created by 2 rays that share an endpoint. So if it was angle ABC, we would have A, the corner in the middle, B, and C as the other 2 parts of the rays. This is also angle B, which is okay if the angle is all by itself, not touching any others. Or if we wanted to put a number on the inside in here, that could be another way to name the angle, angle 1. Alright, so when we are naming different geometric figures, there's a lot of different things that we could see. This one's straightforward. It's just a single point. We use a capital letter for points, and the capital and lowercase does matter, so that's just point P. Okay. When we're looking at this one, this is a line. You can see the arrows go on in each direction, and we could name that a few different ways. We could name it with letters A and B, letters A and C, letters B and C. All of those are okay because they're points that are on the line. Or we could also use line L, and it would be the script L because it's labeled over here, and that's acceptable also. And then this angle, like we said before, you can use the 3 letters, always putting the center, the corner, in the middle. That's called the vertex point, the corner of the angle. You can use that single letter if it's all by itself, or that single number. Okay. Congruent is a way that we can describe different things like segments or angles, and that would mean equal size and shape, and the symbol looks like an equal sign with a tilde on top. Okay. Now we have different types of angles, so if you can remember some of these from previous classes in math, acute angles, they have a measure that is between 0 degrees and 90 degrees, and the M refers to the measure. A right angle, the measure equals 90 degrees. Obtuse angles go between 90 and 180 degrees. Straight angles, the measure equals exactly 180 degrees. And a reflex angle is an angle whose measure is between 180 and 360 degrees. And notice these are all inequalities with not equals. So an acute angle would be one that is smaller. A right angle would make a perfect 90 degrees angle, and we would put a box there to show that. An obtuse angle would be wider open. So this is the acute, this is the obtuse. A straight angle is essentially just a line. And a reflex angle, it is the outer portion of any of the angles above. So it's the back of it, kind of. All right, so just as a recap, to match these, the line would be the one with 2 arrows. The length would be no hat on top at all. A segment would have no arrows, and a ray would have only 1 arrow. Okay, and in order to be able to deal with these, we do need to be able to sketch them and understand what we're talking about. So if I look at this, it has 2 letters, X and Y, and no arrows. That means that it is a segment XY, and X and Y are the endpoints. For 2B, we have L and M, and since there's only 1 arrow, it would be a ray. The arrow is not over the L because that's the endpoint. It is over the M because that is the point that it goes through. For C, we have 2 arrows. That means it is a line, and it's going to go through both point R and point S. And then this symbol is the angle symbol. Remember that when we draw an angle, it's 2 rays that share an endpoint, and that endpoint is called the vertex, and it's always the middle letter. And then the other 2 are each on the rays. So this would be angle EFG. Okay. Now, we can combine angles to make larger angles. So if I look at 3A, it says I have angle 1 plus angle 2. And if I were to combine these together into making one corner, it would now end on this ray and on this ray. I would have to contain all of that section. And so now I would name this with 3 letters, putting the M in the middle because that is the vertex. So it would be angle GMI or IMG. It could go both ways. For B, 1, 2, and 3 put together, all of these, now I would end on this line and on this line. So my angle would have M in the middle again, and it would go through G and J. So it would be angle GMJ or JMG. And for C, it's 2, 3, and 4. So now I would begin here and end here, and I would have angle HMK. And then for part D, angle 4 and 5 together, that would be this angle, and that would be JML or LMJ. Okay. For number 4, to find the measure of the angle. So now we're talking about, in this one, angle M, the measure of angle AEC. So AEC. And when we're talking, this actually looks like there could be 2 directions to go. Are we talking about AEC this way or AEC this way? When it doesn't say the word reflex, like it does in B, we're talking about the smaller one. So angle AEC would be this one here, which would be 85 and 65 put together. And so that would be 150 degrees. For B, we're talking about reflex angle AEC. So now we're talking about going the other way and making the larger one. So it almost looks like the back of the angle, and that would be 135 and 75 together, which would be 210 degrees. And notice that together, if I were to put the angle and its reflex, that would be 360 degrees total, because that would make the full circle. Okay, so for BED, part C, we're talking about this angle, B to E to D. The smaller one is the regular angle, and so that would be 140 degrees when you add 75 and 65 together. And then the reflex angle would be adding the 135 and the 85 together to get 220 degrees. Okay. And then just a few more ideas. So identify the angles as acute, right, obtuse, straight, or reflex. A 90 degrees angle is always a right angle. A 64 degree angle is between 0 and 90, that would be acute. 145 is between 90 and 180, so that would be obtuse. 180 is a straight angle. 210 is larger than 180, so that is a reflex angle. Half of a right angle, half of 90, 1/2 times 90, you would multiply across the top and divide by the bottom. It would be 45 degrees. 1/2 of a straight angle, 1/2 times 180 is 90 degrees. 3/5 of a straight angle, so 3/5 times 180, you would do 3 times 180 and then divide by 5, which is 108 degrees. And then 2/3 of a right angle, you would do 2 times the 90 and then divide by 3, which would be 60 degrees. And then finally we have true or false and explanations. So PQ has 2 endpoints. If you look, it has no arrows. That would make it a segment, which does have 2 endpoints, so that is true. PQ with an arrow, though, has 1 arrow. That means that it should only have 1 endpoint, which would be here, and then the other would go through and be infinite. So this is false. It should have only 1 endpoint. A, B with 2 arrows, that means it's a line. It has no endpoints, true. This line has 2 endpoints, that's not true. Lines don't have endpoints, so this actually has no endpoints. If you look at the hat, we have no arrows, that makes it a segment, so that should have 2 endpoints, so this is false. FG with arrows makes it a line, so this saying it has only 1 endpoint is false. It should have no endpoints. PQ with 1 arrow, that makes it a ray. It has only 1 endpoint, that is true. Okay. Another name for SR is RS. That is false. Rays cannot be named backwards. And the reason is that SR and RS, the end point ends up switching, and that's not okay. If you look at a line where it's infinite, you could say PQ or QP. It wouldn't matter if you went left to right because you're going on infinitely in both directions. So this one is true. And the same for a segment. It really wouldn't matter if you said QP or PQ since both are endpoints. So that's also true. All right, I will see you in class.